Hello, I'm Mr. Lineweber, and this is 4.4 Adding and Subtracting Rational Expressions. When working with expressions of this type, we're going to require what's called a lowest common denominator. And so to illustrate this, I'm just going to do a simpler question that just involves numbers. For example, 1/2 plus 1/3. And so you might recall from previous courses that a lowest common denominator is required. And what we're talking about actually is a LCM, a lowest common multiple. So you're trying to find the multiple that is least and is in common. So for example, when you skip count by 2, 2, 4, 6, 8, and so on, and when you skip count by 3, 3, 6, 9, 12, and so on, we are interested in finding the lowest common multiple. Now there are other common multiples. For example, if you kept going 10, 12, you could go to higher multiples if you want, but you just have to end up simplifying at the end. So that's why we want to choose the lowest common multiple. Now if it's 6, then what we have to do is we have to edit each one of these denominators by multiplying. So for the first denominator, I'd have to multiply by 3. So whatever you do to the bottom, you have to do to the top. And that is because you need to preserve the ratio. For the second denominator, it's multiplying by 2. Whatever you do to the bottom, you do to the top. Now I want to just illustrate the fact that what's happening is the first numerator, which I'm going to call numerator 1, and the second numerator, numerator 2, there's typically always this process going on, like some editing of the denominator, then therefore you have to edit the numerator, and then you get these new numerators. Basically all you do once you find the LCD is you combine with whatever operation it is. In this case it's a plus. So if we're plussing, we're adding, so that's what's going to happen here as well. So we can rewrite the next step as 3 times 1 plus 1 times 2, and it's going to be all over that common denominator, because what's happening here is this is 3 over 6, which is the same as 1/2. This is 2 over 6, which is the same as 1/3. And now what we can say is that we have 3/6 plus 2/6, which altogether makes 5/6. It's like they're a like term. You have to only add sixths together. It's like a like term. All right. So let's extend that to polynomials. Before we just jump in, I'm just going to remind you about the importance of factoring the denominator before you get started. And then once you've done that, it's important to state the non-permissible values. I can't overemphasize this enough, that this first step is crucial. If you do not factor the denominator, you're going to end up in some serious problems later on. Okay, so this first question, I'm only going to do A, E, and F just to establish the polynomial lowest common denominator process, and also we can have a nice little review of non-permissible values. All right, so for the first one, the LCD, the lowest common denominator, between 5x squared and 10x. With the number, it's pretty straightforward. It's 10. So some people want to just take 5 and 10 and just multiply them to get to 50. That is a common multiple, like 10, 20, 30, 40, 50, and the other one 5, 10, and so on all the way up to 50. You can do that, but it's not the lowest common denominator, and you just have to simplify at the end later if you select 50. But the better strategy is to go with the lowest denominator, which is 10. If you see that, if you just multiply that by 2, then you're going to get to 10. And so simply just multiply the top by 2 as well. So our LCD will be 10. And then something involving x. You can see here that we have an x squared and an x. And what we want them, at the end of the day, we want them to match. So how can we get an x and an x squared to match? Through multiplication. Like remember here, I had to times by 2 there. So we're trying to multiply. So what we're going to be doing is we're going to be bringing the variables up. So this x on the right here, we're going to have to times by x. Whatever you do to the bottom, you do to the top. And then our lowest common denominator will be 10x squared. So this is an example where you have monomials only in the denominator. The second example here at the bottom is when you have binomials only, and while it might seem scary at first, it is actually easier than the monomials. Simply just what I like to do is wrap these denominators in brackets because they are treated as an object, of themselves, a binomial. So when you're trying to find the LCD for these two terms, you simply just have to multiply them together. So the binomial is going to be k plus 2 and k minus 8. This process always works, and then it's kind of like a game. It's like, what does this denominator have that denominator is missing? So like this denominator will need a k plus 2. Whatever you do to the bottom, you do to the top. The other denominator needs a k minus 8. Whatever you do to the bottom, you do to the top. And then you see here that we're just going to take this product minus this product, all divided by the LCD, and then you can move forward that way. The last example here, this is typical of what we see in 30-2. It'll have monomials and binomials together, and it'll also have a beginning step where you have to factor before you get going. So I'm just going to rewrite this. And again, you only have to factor the denominator. I'm going to take out a 2. And over here I'm going to take out a 3. Now you see that they don't quite match. And in fact, you see an x squared term here. That's a cue that you probably need to keep factoring. So that's actually a difference of squares. So I'll keep going. X minus 1, x plus 1. And now they're getting closer to being the same denominator. For example, x plus 1 binomial, x plus 1 binomial, they're very close to being matching up. All I have to do now is match up this x minus 1 and the numbers. So on the side here, I'll just jot down the LCDs. So between 2 and 3, the first multiple is 6. We've already established that at the beginning. And then I'm, of course, going to need the x plus 1 term, and I'm going to need the x minus 1 term. So now I got to make sure that both denominators have a 6, so I'll have to times by 3 there, and times by 2 here. Now these will be 6. They both already have the x plus 1, so I don't got to worry about that. And then finally, I just need to incorporate this x minus 1 term. So that one's already there, so I just need to add it here. Pardon me, not add, it's multiply. You have to multiply it on. It's like you're attaching it with multiplication. Whatever you do to the bottom, you do to the top. Now what we'll do is we'll take this numerator, subtract this numerator, all divided by this lowest common denominator. Now just a quick review on non-permissible values. Remember, when you have x or any variable in a monomial by itself, you're going to have that variable not 0, so in that case x not 0. When they're binomials, you simply just do the opposite of what the term says. So a k plus 2 would have an opposite, would be negative 2. A k minus 8, the opposite would be a plus 8. And on this last one, because 6 is always just 6, it's never 0, you don't have to include this one. There's no variable there. So if it said 6x, then yes, we would have this. But because it's not there, you do not need that. It's not required. And the only non-permissible values are x equals negative 1 and positive 1. And we often write that a little bit simpler as this. Whenever you have difference of squares, this sort of symbol comes up, the plus or minus. All right, so I think we're ready to actually jump into some questions. So nothing to factor because they're only monomials. Now we want to establish the LCD. So I could just simply times them. 8 times 4 is 32. That will work, but it's not the lowest common denominator. In fact, I can just simply get to 8 by timesing the 4 by 2. That will work. And then I want to bring everything up to the highest power that's there, so that's going to be x squared. So the first one I don't need to adjust, it already has that denominator. Now the second one, and this is what I like to do, I like to use a different color pen and edit right on the question itself. So I'll put 2x there, I'll put 2x there, and now you can see what's going to happen. I'll have up here 1 times 2x, that's just 2x, all over, of course here is the 8x squared. Now I can write it in that familiar form where it's numerator 1 plus numerator 2 all over that lowest common denominator. And because I can't simplify that any further, this is actually complete. And all I have to do is jot down the non-permissible value, x alone in a monomial, x not 0. If you do part B, you'll end up with a trinomial in the numerator, so good luck with that one. Check my notes on my website. With part C, we have a monomial and a binomial, so the only thing I can actually do to find this lowest common denominator is to just multiply them together. So you play the game where it's like, what is the one term missing that the other one has? And so you can edit with a different color pen. So that'll need an x, that'll need an x, timesing. This will need an x minus 2, this will need an x minus 2. And now let's grab numerator 1, that's 2x. Let's grab numerator 2, that's 3 outside of an x minus 2. And then we want to grab the operation between them, which is a minus, all over that LCD, which is x minus 2. Now, here comes the algebra. So you have to simplify the numerator, which means you need to collect like terms. And often there is a distribution step first. So you can see here that I got to distribute this minus 3 through the brackets. So very important here that you distribute the negative. Just like in previous notes where we were talking about factoring out a negative and signs will change, now we're distributing a negative and so signs will change. So let's go through this. We have 2x, and then we're going to get minus 3 times x, and then minus 3 times minus 2, that's going to be positive 6, all over the LCD. This is going to simplify to negative x plus 6 all over that LCD. And you can actually factor out the negative on the lead coefficient to make it look a little bit cleaner. Take out a negative and you're left with x minus 6 like that, all over the LCD. Jot down the non-permissibles, and that question's complete. With letter D, I'm just going to quickly show you the distribution of a negative as well, because it is the most common mistake that's possible. When you're doing subtraction, you have to be careful that you actually subtract this entire algebraic object, the binomial itself. Notice that I'm keeping this question simple. They already have the matching LCD, so you don't have to worry about doing any multiplication at first. The LCD is x minus 1. Note the textbook or the workbook sometimes does not put the brackets in there. I like to put them there to help me. So we have 5x plus 1, the first numerator. The operation between them is subtraction, so we're going to minus there. And then we're subtracting that other binomial 3x plus 1. And this is the important piece here, that when you subtract, you're subtracting this entire parenthesis, so it's like you're distributing a negative 1 through that bracket and simplifying the top by collecting like terms. We end up with just simply 2x, as the 1's look like they're canceling, and the common, or pardon me, the non-permissible is 1. So these are the U tries. You'll have to factor these first before you get into it. And like for example, you see this x squared business. You never want to start putting like, oh, 3x squared here, 3x squared here. It's just going to be too nasty. You don't want to do that. You always, always, always factor first before you get in there. And you only have to factor the denominators before you start. This one here, you'll see later in the notes, it's already worked out. So if you try this, the notes has it. It's right here. I'll try this one here for you. I think what you need to realize is that sometimes when there's not brackets, make sure you put those brackets down there for yourself. So you remember, oh yeah, that 2y minus 3, it's actually, you know, a binomial. You got to treat it as one single object. So let's look at the LCD. I like to just jot down the binomials because you know they got to be there. And then think about what's going to be the monomial that goes in front here. So right now we got a 4 and we got nothing. What goes there? Oh, it's a 1 placeholder. So what's the LCM for 1 and 4? It's just going to simply be 4. All right. So now I'll start editing these denominators. So what do we have here? This will need the 2y minus 3. This will need the 2y minus 3. Now that LCD matches. Over here we're going to need the y plus 1, playing that game. What do you have that I don't? And also missing the 4. Make sure you put it top and bottom so that they match, preserving that ratio. Now what we do is we take this entire numerator plus this entire numerator all over the LCD, and you can see how I keep things organized, and you're going to have a little bit more success if you stay organized. 4 by minus 2, that's minus 8, multiplied by that binomial, plus a 1 outside of that binomial, all over the LCD. And notice that I'm being a little bit lazy there because you don't have to write it out over and over and over again as you're progressing through this algebra. Distribute and collect like terms. Negative 8y minus 8 plus 2y minus 3 all over that LCD. I get like terms here and here. We got minus 6y and a minus 11 all over. Now as I look at this numerator, say that was a 12, then I probably have to do one more step and take out a 6 and all that. But because that's 11, there's nothing left in common here. I can't further simplify, so I know I'm done there. I am just going to jot down the LCD because I want to write my final answer. And all I need now is the NPVs. So let's look at these terms. Here's a monomial. It does not have the y, so I do not need y naught 0. This one's easier, just simply the opposite of plus 1. And now when you have a binomial with a coefficient, you got to remember that this has to be divided out. So the opposite of minus 3 is a plus 3, and then you need to divide out that 2 such that this term goes to 0. So those are your non-permissibles. So when you're looking at this one, you might just want to just jump right in and be like, oh, 3y plus 18. Remember, you don't want to do that. What you want to do is you want to factor first. So I'll rewrite this. Take out a 3. Wrap a bracket around that denominator to see how it matches up. So it's like, look, after you factor, these already match. So all I need is a 3 here and a 3 here. And then life is good. Use a different color, and then simply just take this and combine them. I'll let you guys finish that one. Here's a really common example where you got a difference of squares in the denominator. And you can see down here another worked out example. So I'll let you guys try this one. This is really common for the diploma where they like to put simple difference of squares in there. You got to make sure that you are able to notice the pattern. 2 square numbers separated by a subtraction sign. Two squared terms separated by a subtraction. Another similar one there. And I'll just finish off the video with this challenge problem. So typically in 30-2 you don't see problems this difficult, but there are some questions in the assignment that rely on this. So I'll just quickly talk about it. Taking out a 3 in the denominator, and then approaching this next GCF. When you look at this, you look at the order of the variables. This starts with the x, this one starts with the constant, so this one is in the wrong order. If you cross it out and replace it with how it's supposed to be written, minus 4x plus 12, then you can see here that like this negative on the lead coefficient, we've talked about this, this needs to be positive. So I'm going to factor out a negative 4, and then that ends up being x minus 3. So that establishes this x minus 3 is the same as this. So that's part of the LCD, it's already there. And then a nice little trick here to understand is that the numerator on the right here, like there's a positive 1 for the coefficient there. So what we have here for coefficients out front is a positive divided by a negative. So this whole rational expression is negative. So I'm just going to rewrite it so that you can see what's happening. So we have minus, the whole ratio itself is negative. So it's like I took this up to the side here because the top and the bottom are alternate signs. And so this minus minus, subtracting a negative, so to speak, means that you can just write it as plus. Then you can continue on with a similar style. You'd have to get this to 12 by multiplying by 4 and 3 respectively, and then you can finish it off. So check my website for the solution for this, and you'll see some of these in the assignment, but not too often in the 30-2 exams. All right, well, good luck.